words I wrote on the website. I can't remember what that was. My name's Adrian. I go by Threlfall. I work on the red team at Dropbox, and I'm also their lead for ML security. I'm on the staff here, kind of, I guess. And I do have one staff announcement. Please take your glasses back to the bar when you are done. Thank you. In the last year or so, couple of years, I've done training and presentations at Kakalaki, DEF CON, Black Hat, and so on. And I'm about to take you through, hopefully, some things that you will enjoy. Go through what do I mean by offensive ML, what the future of that is, like what's next for attackers. But with that piece of information I just told you, by what I mean what's next, I kind of mean like what's happening right now. We'll do some examples, and then I'm going to just give you a story. All right, let's try and get on with the presentation. So ML and things is everywhere now. And, you know, over the course of the history of computers, we've seen sort of a hockey stick recently, not just of LLMs like ChatGPT, but of all kinds of ML are way more effective than they used to be for a variety of reasons. It's probably hard to see down the bottom, but, you know, I did ask Google, how many times is it appropriate to say AI in 45 minutes? And I'm going to go for, and I'm going to try and do 0. How about that? 0 from now. Yeah. Okay. But the usefulness story for ML is a little bit different for red teamers. And what I mean by that is, like, we really haven't gotten the value out of ML as other aspects of security, namely defensive aspects of security, and also just like general business, I don't think gets the same value out of ML. You know, and people are using LLMs to speed up a variety of tasks. We saw in Dr. X's talk like some pretty grounded and realistic looks about what that looks like. And of course we see big improvements in social engineering. But in terms of offensive capabilities, the story is not amazing. And what I mean by that is like where it's been built into attacker payloads, like ML in a cobalt strike implant, ML in a sliver implant. Like there's not a great deal of that goes on. Or in smart malware design. And but we're going to do that. We're going to do that today. I think the reason we haven't seen that is because like it never really mattered. Like if you wanted to bypass a business's defenses, you didn't have to get particularly fancy about it. Like the basics and consistency with the basics got you very far. But I have noticed in the last couple of years a shift in the language used by red teamers when discussing their operations. And I mean the kind of conversations that happen at conferences between people. Around before times, you would hear people say like, yeah, I got in and out totally clean, like no one detected me, everything's fine. But nowadays I hear people say a lot more like, I got it done before there were detections and people caught up with me. That's like there's a shift in the language of just sort of like people are getting detected a little more than they used to. Maybe it's not happening quickly, but it is happening. And you know, that's because of a range of ML-based detections in security tools like EDRs. They're a lot better than they used to be. Like, do you folks remember when, say, something like Carbon Black came out and they were like ML all the things in like 2012 to 2014 and it was a bit like funny? Yeah, but a lot of that stuff's like pretty decent now. And defensive ML is like a huge component of security, the money, the business, and everything. So if you're an offensive person, you look at this list and you're like, whatever. But all of these places are trying to build a wave of ML to crash down on you. And if we made the same list of defensive things for red team things that are ML, it'd be basically an empty list, right? Like there's no one helping you use ML to get better. But if defensive ML is getting better, then what do we do about it as attackers? We don't have that huge list of companies, right? ML-based detections that are used defensively are typically black box, meaning like if you go to like the console for something like CrowdStrike or your phishing web page detector, it doesn't actually tell you the exact reasons why there was a detection. It just says there was one. And that's intentional. They're trying to preserve the IP. They're trying to preserve the detection. But what we can do here is we can use these technologies to our advantage to make better attacks. Over the past year or two, I've been working on this playbook, this framework, of offensive machine learning TTPs and also adversarial machine learning TTPs. My motivation for this was when I got interested in ML, I read a lot of papers. Many of the papers didn't have code, so they weren't implementable. Like it was a blog, as far as I'm concerned, right? Like if I can't reproduce your thing, it's a blog. The other component is a lot of adversarial ML attacks required either an extraordinary amount of access or an extraordinary amount of knowledge that someone like me as a red teamer is not going to have. I wanted access to like practical things that I could use as an operator to just like press buttons and make things happen. So the site is broken down into categories that describe the access you have. So if you want to do adversarial ML and you click that button, well, then the next category is going to ask you, do you have access to an API? Do you have access to embeddings? Like, what can you see? And then it tells you the attacks you can do based on what you see. And they're only practical attacks on the website. But what I learned through this process was that there is, like, fuck all offensive ML. And as we talk about offensive ML, I need to disclose to you that what I'm talking about here is unorthodox. It's not considered like the state of things. There's very well-regarded authors of this paper, well-regarded paper, that say that adversaries don't do machine learning. Like they don't attack ML systems. They don't give a shit about your ML systems. But you know, this is me standing here saying like, yeah, I think they do. We need to reconsider that opinion. So let's dive into why, like, even if you believe this opinion, you should probably hold this opinion, like, gently and not really firmly, because it's changing. If you want to know more about computing gradients, that is, like, attacking ML systems with maths, then tomorrow there's a talk by FaceTip, who is, I believe, in the room. I swear I saw him walk in. And in that talk, you will learn a lot more about, like, actually attacking gradients. But let's address why some authorities in the space would say that attackers don't compute gradients, that they don't do adversarial ML. They say that because if we take malware detection, like ML malware detection in an antivirus system, you have to deal with static checks, dynamic checks, signature checks, you know, and so on. And the ML components that are in green in this diagram, they make up just like a small component of detections. And often by the time that you deal with the other things, you've sort of defeated the ML component for free. But that's not always the case, and it is changing. The other thing is that a modern C2 framework, like Sliver or something like that, gives you defeats many of the blue things for free. Like signature checks and static checks, it's kind of like built into the tool, you get that for free. So the idea that attackers don't think on gradients is sort of based on the idea that they haven't already automated the other parts, but they have, right? No one really thinks about signature checks, you get that for free. We've got a question.
Could you just do a short gradient discussion in the context of ML, like a two-sentence definition of how this fits in the context of what a gradient means?
Yeah, so what I mean by gradients in this context is it's a crucial step for generating adversarial examples. That is, generating something that defeats a model, right? Are you familiar with that attack on, say, like Tesla cars that used a special sticker on a stop sign? And then the car just like blew through the stop sign? That's an adversarial example. So they computed gradients, you could say, to basically determine the optimal picture that would not appear as a stop sign. So one thing to note about apex attackers, and in the non-recorded section we described an apex attacker, they don't want to get caught, right? It's an international incident, it burns months or years of work, it's just a bad time. You don't want to do that. They already do a shopping list of evasion techniques. So what's one more, right? If you're doing a thing for months and you can, in the course of a couple of hours or days, drastically improve the confidence that you won't get caught, you will do that thing. That's just common sense. And there's a guy called Jackson Thurasami. I'm pronouncing his last name wrong. I apologize, Jackson. You're awesome. He has an awesome blog post describing why and how attackers leave nothing to chance. And it is an excellent read. For attackers to get their hands on gradients or get their hands on enough of a model to reverse it, you could say, there's a number of ways that they can do that. The first is through a supply chain attack, right, that puts them right in the face of machine learning systems so that they can steal them and defeat them. The second is through exposed services, that is like ML services or ML agents, like say an EDR agent on a computer that isn't appropriately expecting an attacker to try and loot the model off the device. And of course you have straight up adversarial ML. More on that in a moment. We're starting to see the cryptocurrency miner folks targeting ML pipelines. And this is basically a free bug bounty in a way for them because they want to get on ML pipelines because they have GPUs, right? They just want to mine coins. But they have access to an ungodly amount of data and access when they pop these systems and they waste it on cryptocurrency mining. At least from my point of view, they waste it. I mean, they make good money. So let's do a practical example of something I do currently using adversarial ML to make my ops better. If you want to phish a business that has good defenses, you have to think about a good domain, the provenance of the domain, the message you send and the links that are in it, all that kind of normal stuff. But there is a set of ML rules that are baked into phishing web page detection. And that is an additional thing that we need to defeat now in certain products. So if we want to defeat something like this where the model is controlled by the vendor, we can't just go look at the model. We need to figure out a way to learn about the model indirectly. We have a range of options. Some of them are legal, some of them are not. One option is that we literally just steal the model from the business and have it forever. So think about some of the attackers that are currently inside Microsoft from certain threat actor groups that are targeting security engineers in Microsoft. Why are they doing that? What are they looking for? What are they trying to steal? So what we can do, though, is we can use open source defensive tooling and data sets, that is, tooling that defenders have released to the community in good faith. They can be turned around and used adversarially, unfortunately. So in this example, we take an anti-phishing data set that is meant to help aid in the detection of phishing web pages. And we can use it to generate better phishing web pages. So in this GIF, what we're doing is we are generating a bunch of different HTMLs of a login page, throwing it at the model with different iterations of the HTML, and then deploying the version that this model detects the least. And of course, we do all the usual steps of a good domain with good provenance, with the blah, blah, blah. We're just also now doing ML. So when you do this, the reason this helps is that a web page only has so many features. There's only so much in HTML for a model to train off of or learn off of. So even though we don't have access to the proprietary model, HTML only contains so much. And what happens now is we actually learn what makes a detection. We don't get wishy-washy messages like, There was a detection. We get the actual data about the thing that it cares about. And what we learned, for instance, in this one, is that two things have a big outsized effect on the detection of a phishing web page. One is if it doesn't contain accessibility features for the disabled, that's bad. You need that in your phishing web page. The second is if you include a lot of external links to things like the Alexa Top 100, which I think is a known technique that wasn't learned through data science, that also has an outsized return in making your thing run clear. You can try this for yourself right now. So this code is called Raised to the Ground. It's by a guy called Biagio Monterulli. He is a French PhD who does adversarial research, good practical adversarial research. Another way that came out in 2019 is by Muhax, Will Pierce. And this actually inverted the proof point phishing detection model by querying the model repeatedly because of things they mistakenly exposed. So let's move on and try this same technique but do it for malware creation. So just one more note about why we will want to do this for malware. Once again, even if you're a red teamer or a consultancy company that has, through a shell company or through some mechanism, bought an EDR, when you test your TTPs against the EDR, you get useless messages like this. High severity machine learning detection. File meets ML algorithm attributes. No details about what about the file is a problem. So attackers and defenders don't get any hints about what to look for to rule out a false positive, and attackers don't get any hints about what to strip out of their malware. They do this because they don't want their shit stolen, they don't want their IP ruined. But we can take defensive models like Ember, which was released by Endgame, and we can use a defensive model to tune the malware that we develop with Sliver or Cobalt Strike to make it run green. So what we do here is we submit our portable executable to the Ember model that we deploy locally, and we look at the outputs of the model that drive a detection, right? It's looking at something like 3,000 or 4,000 features of a binary and what their commonality is with known malware samples from 2 million malware samples. And when your PE overlaps with a known malware sample, the score goes up. But it tells us the exact things about your PE that are bad, so you can change them. Some of the most important things about your malware samples that get you caught are things you may not have ever considered. Number one being the timestamp. You take Mimikatz, probably the most instrumented file, and you run it through Ember. One of the things it cares about the absolute most is the timestamp. You backdate that timestamp from before the creation of Mimikatz, and you see a 40% reduction in the confidence of a detection. So we're removing guesswork, right? In the past, what do we do when we want to wrap an executable to make it run green? We pack it, we strip strings, we do things like that. We do them because people told us to do that. But now we're doing data science, and we're doing it because the science tells us to do it. We still do many of the traditional techniques, but this takes a couple of minutes. It's not hard. This works because of a package that we run on top of the model called SHAP. SHAP stands for shapely values. I'm definitely not the person to explain game theory things to you, not a very smart person, but what shapely values are effectively is if we picture a game of chess, we can assess a game of chess after the fact to learn what was the move halfway through the game that sealed the deal. Because there's always something in a video game, in an RTS, where you know you've won even when you aren't done. And we're doing the same thing here. We're looking at the top values of our binary that make it bad, and then changing them until they're green. So instead of guessing and learning through failures and backroom conversations at cons, we just do surgery. We do data science. It's like a complete change in medicine in a way, right? Some of you might say, Adrian, the models that you're describing in an EDR like Sentinel-1 or CrowdStrike, they're proprietary. This won't work. You're using an open source model and then expecting the same thing to happen somewhere else. If I was like a real deal, scary attacker, then I would want to care a lot more about those models and try and get my dirty little hands on them a bit more. But there is a really important concept you need to note, which is transferability. Transferability works even on the biggest, most complicated models. Here's some research done by myself and some colleagues on LLMs, ChatGPT, Gemini, Anthropic, and so on. And what we see here is the attacks that work on one LLM work on another because they have much of the same data set and many of the same features and so on, right? So we can extrapolate that to these smaller models, the proprietary models, that transferability is a thing. There is an Easter egg in the OffSec playbook. Every single adversarial attack lists if it transfers or not, based on whether I've seen it transfer, not a guess, whether I've seen it transfer. And you can find it in the source code on GitHub or in the hidden properties of the HTML. It's not publicly exposed. So I think this is a sophistication leap in how attackers are behaving because you're just removing guesswork, right? That's a good thing. Okay, the subject of this talk is succulent Chinese meals. I have in my hands a gift card for a succulent Chinese meal for the person who answers this question. What is another area of OffSec that we could do something like this to, that we described for phishing or malware creation? Where else could we do this? Hardware Trojan injection. Do you want to tell me a little bit more how you think that might work?
So you'd be able to spin up a large number of potential net lists that you could run against a security model or some golden standard that they're using in order to determine which type of hardware Trojan you could insert into the system that would have the least amount of attack.
Oh, come on, Workman, put the PhD away.
Okay, not bad. I want to hear a couple more before I decide. What do we got back there?
How your C2 framework communicates?
Yep, okay, cool. So you're thinking about NetFlow classification, that kind of thing?
Yep.
Okay.
How the ML classifies what packets look malicious,
Cool.
what parts of the packets are malicious, things like that.
Zach.
You just be in your model to see side channel attacks and see where you're at.
Side channel attacks, last one in the back. Yeah, okay, cool. I'm going to give this to the NetFlow classifier because in the unrecorded part of the talk, they are actually doing that and I've seen it. So good for you. Come up and claim your prize, please. All right. I'm going to make you shake my hand like a politician. So we're going to hold this here, and we'll go like this, we'll look at the camera. Yeah, there you go, enjoy. Okay, let's talk about some other automation gaps that we have in OffSec, and this is in Hackbots. The big thing with Hackbots right now is using LLMs to programmatically do web app attacks and so on. And there's a lot of hype around this. I think I've tried every single Hackbot. At least it's open source, and there's two areas they fall down. One, very noisy, very loud. Not good to stick on an endpoint. You've just lost that endpoint. Not too bad for web app attacks where you can make 1,000 requests and it won't get you banned. 1,000 queries on an endpoint, you can forget about it, especially if it's got defensive tooling on it. Most importantly, they lack context. They don't know your environment and they're actually not really even tuned to do hacking in the first place. So there's a lot of like messiness there. Some decent results coming out in CTFs. I think a lot of people in OffSec and security at the moment are just sort of like waited with a holding their breath for LLMs to like solve a lot of problems. And I don't think that's quite as close as many people think, which means these other kind of ML things that I'm describing have a lot of importance. We saw in Dr. X's talk that traditional ML, stats, is still outperforming an LLM in many categories, right? And it will for some time because of the inherent nature of like generative, the word I can't say. Some problems with the hackbots is the data they have. Why do they not have good context about attacks? Something that red teams are terrible about is their telemetry. Your C2 framework generates a lot of telemetry about everything that you did and what are you normally told to do with it after an op. Delete it. If you are a consultant, you're kind of stuck because it's full of customer data and now you can't train a model on it without an extraordinary uplift. But if you work at a business and you're targeting that business, it's a little easier, right? Because that's one model for one purpose. If you want to do more data science, you need to think about flywheels. This is the process where good, clean data coming from, say, users or telemetry makes better models. What happens when you get a better model? You get more telemetry, better telemetry, and the model just keeps getting better. It keeps getting faster. This is how things like Netflix and Facebook like tune all their recommendations. It's a flywheel. Term was coined by a fellow called Jeff Halton, who built many of the ML systems at companies like Microsoft. And if we think about flywheels, that is, a spinning disk getting faster and faster and faster, what doesn't that do well? It does not change direction very well. A blue team's defensive ML can be pictured like this outside spinning disk. You have all the data, attack and benign, across multiple customers about the behavior of something like an EDR. It's a very fast spinning disk. But when you need to change it, it's very difficult because there's an expression in ML called changing something changes everything, which means every time you change a model, you're effectively starting over. And it's very difficult to make sure that when you change a model, you don't fuck up all your detections and get a string of misses or a lot of false positives. Red teams have an inherent advantage here because even if they have a flywheel, it's tiny. What do tiny flywheels do well? Change direction very, very fast. So building an adversary flywheel, I think, is really, really important. This is what I'm talking about is the tools, tactics, and processes where attackers gather data about what they're doing by any means that is legal to them or whatever, and build data science into their operations and their day-to-day work. You leave nothing to chance. You eliminate a lot of guesswork. You enable the creation of hackbots because you can actually teach them hacking. And you get much better evasion for free. And if you're a consulting company, this is going to be tough because you have so much client data in your models. So I'm speaking, if you're going to look at this and you're a consultant, like, have fun. So to sum up right now, offensive ML is where we apply ML to offensive security. We get more automation, we get better phishers, we get better payloads. Adversarial ML is when we attack ML systems directly. We do need to be doing both where appropriate. When you build a flywheel, you leave less to chance and you safeguard against future creep of automation because you're building the automation. A lot of sophisticated ML attacks are quite easy in that tooling exists. You don't actually have to like touch a lot of math. I want to talk you now through how an attacker such as myself, working on their own, can attack ML systems through supply chain attacks, through the machine learning pipeline, and get red team objectives, get you access to models, get you access to a lot more information to make you more effective in the future. And what all that means is, like, think about models in your business and your intellectual property of your business as an objective, as the target, as the end game. You know, even as a smash and grab, like, it's important. I presented this story at Black Hat Asia like a month ago, and I presented it with a defensive partner at work, Merbear, but I'm just going to go through the offensive component today. Bottom line up front, models themselves can contain malware. They are full-blown executable programs, which means that you can hide anything you want inside them. We see down the bottom, it might be a bit hard for some people, is that when the model runs, it's leaving a bin on disk, and that probably stands out a little bit, but actually when you fine-tune models, it does leave a bin on disk. So that's kind of normal. So to do this, or to do many of the ML things that I've described to you, like, I have no formal qualifications in this space, you can just start. Like, if you can use the C2, you can do all of this stuff. I liked this getting into ML pipelines because you get quite permanent access and you get immediately next to stuff that matters, like a lot of data. A lot of your business's best data is in the ML environment because it has to be. I don't like doing lateral movement. I've never been particularly strong at that. And so it's really cool when you get a shell and it's where you need the shell to be. Like, who wouldn't want that, right? So we're going to do a case study in red teaming with a model to do a supply chain attack. First of all, let's pick a target. So machine learning engineers go through a process that looks like this to pick a model for certain tasks. Not all of them. Some of them, like Dr. X, are very diligent. They will say they want to do feature extraction, like pull out, names and places from a sentence. They'll look up entity extraction on Hugging Face or a repository of models. It's like GitHub for models. They'll find the one with the most stars. This one has like 9 stars and it's the most popular. And then they download it and run it. So that's awesome. That's good for me. This is good because when they download and run the model, they're going to experiment with it right away. They need data to run the experiment, so they drop it in the ML pipeline. Not all of them, but often. What that means is when the model executes, it's executing right next to very sensitive, good data, and it's executing near other components like in a traditional software pipeline, like stores for models and different things like that. You get really, really good access when these things detonate. ML teams are optimized for experimenting. That's their job. And they often are thought of inside of the business as people doing experiments, not people running a production service. But they do have all of the data, limes on theme, on brand. Once again, very fast and efficient looting here. Close proximity to restricted data. And we see heavy use of things like Kubernetes in these environments, which make detections teams' jobs much more difficult because you're adding these layers of abstraction. There's also very little you can do in an ML environment that looks like an attack. Because what's an ML engineer or their code doing in an environment? It's reading an extraordinary amount of data and doing things with it, which is exactly what an attack is doing. I mentioned Hugging Face before as being the place where a lot of models are sourced. It does a lot to make this attack work. The first thing they do that helps make the attack work is you can go ahead and register just about any namespace. Many of them are available. And they just kind of work. There's the font. Sorry if you're in the back. The font on Hugging Face is not great for typo squad attack detection. Like your L's and your I's look too similar, that kind of thing. And most things, the social validation aspects, like are very low counts, so they're easy to bot up numbers. You can register an org pretty easily. You make an account with a Gmail or a burner email, and then you just sign up with the organization username you want, and then upload a nice looking profile picture, and now you're Amazon, AWS, or whoever you want to be. When you register an org, say you've registered it with a Gmail, and you've registered Amazon or whatever, you can invite people to that company like Dropbox. I've done an excellent job here with my redactions. You can, from the Gmail, if you send an invite to a member of that company, the email originates from Hugging Face, so it looks quite legitimate. The other funny thing that happens is I have parked a number of businesses on Hugging Face, and people who work there just like, hey, let me in. And I let them in and give them write access. I've gotten around 12 bug bounty submissions from this technique. 8 paid, and the rest said that I was socially engineering them and wouldn't pay. That's fine. I probably was. But the most important thing is, when you make an organization and camp a company name, people do just ask to join. So I jump and look up the name on LinkedIn and confirm they work there and let them in, and I give them write access, and then they start like working in there like it's their business's environment. Now that we've done that, we have to actually like infect a model. We either need to place one there that they like, or we need to like change one that they gave us. What we do, the easiest way to do this, there are many ways described on the playbook. The easiest way to describe in a conference talk is using a TensorFlow Keras model. So we start by defining a TensorFlow Keras model, and then we add some functionality. You stack in the regular things that belong to the model, and then somewhere in there you insert what's called a lambda layer. This is a pass-through lambda layer. What that means is it does not change the behavior of the model. It will still be as accurate as expected. It will do all the things it's supposed to do, but with the addition of code execution along the way. Inside our code, we call out to an AWS resource or whatever you choose and have it download a binary that contains our, in this case, a sliver implant. And then we have it execute like normal. And then the model continues with its normal behavior, which is effectively designing inputs, outputs, and then saving the model with a name, defining how we want to compile it, and so on. All normal things. Because we're hosting sometimes publicly a malicious model, we don't want this detonating on random people's computers. So on the remote host, on AWS in this case, we define, this is Rust, this isn't Python, I'm sorry. You define CIDR blocks that you want to be allowed to download the malware so that random people can't get it and defensive people can't get it. In the end, when you upload a malicious model, you get something like this. Now, some of you who haven't messed with models before, this model looks exactly like it's supposed to. This is a normal model. You can't tell that anything's bad in here because the badness is serialized in this protobuf file that's 7 kilobytes in size, a normal size. And so in order to find the badness, you would have to download that serialized file, unserialize it, find the badness, do the thing. It's like a whole investigation. This will execute reliably every time. So what we end up here with is the working malicious model. To summarize, we have an attacker hosting badness on Hugging Face, tricking, coercing, whatever. Victims, download, execute model, it phones home, we do the thing. Okay. The normal execution place is during training and tuning and compute. It doesn't really matter to me which environment I get. Honestly, they tend to both look very similar in terms of the secrets on disk and the level of access they've got. But once again, we're talking about you having direct access to your business's data lake, to your business's like massive data stores. That's not good. Post-exploitation in this environment was really tough. I had basically no things to read to learn what to do, except a lot of kind of fairly academic things that obviously had never have been run through a C2 framework on Linux. If you've ever done a Linux C2 implant, you'll know that they can be a little fucky, a little sensitive, and if you're running tools that go interactive, it tends to be awful. What I wanted to do here was I wanted to do some adversarial ML attacks with my access. And I wanted to see, is that even practical? Can you, over a C2, actually mess with something like an LLM? And the answer is yes. And how it starts is, in many of the environments you drop in, you wind up with something like a lot of secrets on disk just living in environment variables. You see a lot of custom tooling that lets you into things like model stores so that you can edit existing models. And you see very little defensive tools. For movement, I found by a fellow called Alkeet an Nmap script that helped me map out what I could touch that was ML related in the environment, like the model store, for instance. And what I also noticed, and this is documented in the playbook, is so many ML tools have no authentication, not even as an option. They picture this very secure onion, and the ML ops tools are in there, and no one who isn't an ML engineer will ever get at them. I wanted to poison an LLM because, it's the hotness. And that sounded really, really difficult. And it is, until I found this thing called Easy Edit. Easy Edit is an alignment tool. It's meant to help you take a compiled model and change its behavior, like if it's saying rude things it's not supposed to say, or you want to address a safety issue. It's meant to help you configure hard code answers into a model to affect its behavior. And it turned out it was the easiest way for me to get my results and poison a model without doing any, ML, so to speak. Certain industries, this kind of access to a model could be devastating. Think defense, and we alter a model that does missile detection or whatever, that could be really, really bad. Or a car or something like that. Easy Edit can be pipped onto the disk, but it can also be dropped as a binary through your C2. Because the ML environments have really bad detections, although it's terrible OPSEC, you can just pip something onto a disk and it will likely be okay. But it's so easy to use Easy Edit to mess with an LLM. You literally write basically in plain English the thing that you want to change, the question from a user, the expected ground truth answer, and the answer you want. And now you've got the new answer that you're looking for. So that was successful. Let's talk a little bit about the detection stuff that I noticed. Hugging Face is doing malware scanning of models. Thank you. They are using a tool called ClamAV. ClamAV is not actually really built to look at a lot of Linux files and it's actually not built to look, sorry, that's incorrect, let me go over. ClamAV is not actually designed to look at model files. That's not its intended purpose. It also caps out at 4 gigabytes. Your average ML model is in the hundreds of gigabytes. There's also a lot of hilarious bugs on Hugging Face. One of which is, if your model name is 50 or more characters long, it will never get scanned. This is a note from an EDR vendor that found me in the process of an attack in an environment that they were monitoring, and they flagged it false positive because they decided that bin living on disk was actually normal ML behavior that had dropped in that was phoning out to a random AWS address, that was phoning out to a domain that I hadn't put a lot of care and feeding into. So there's a lot of, I think the idea that models can be malicious is just kind of news to a lot of people. At work, Mayor, who you saw in my very awkward handshake photo, has written a defensive tool to help you investigate and find malicious models of this category. And if you want to read the story of this attack for bug bounty purposes to replicate on your own, I know there's some other people I've been working with who are doing this for bug bounty. It's right here if you want to go ahead and, do it yourself. All right, I think everyone got their pictures and duckies. There are a lot of other ways to make malicious models, and I have much of this documented on the resource I mentioned. I just want to give you an idea about this window into hell that I've been working on that I really love. These fellas at a Chinese university basically did steganography in a model, and what they did was inside the individual tenses that make up a model, at the very end they started stuffing small pieces of payloads, and then they never got code execution. I don't believe that. They never got code execution, but all they had to do was basically reassemble in the correct order those small bits from the individual tenses, and they had a working payload that was extraordinarily difficult to find. I described this to my defensive coworker, and she wrote to me at work, "Fuck you." So yeah, this is an amazing technique, and you can get code execution with this. It's done, and it's documented on the website. Multiple ways. I want to just take you back to the playbook for a minute. So once again, the motivations for this was practical adversarial ML for people like me who don't do ML. And also what to do when you're in this unfamiliar environment, what to do next. And this is the structure of the website to help with that. So I hope you get some good use out of that. I know, for instance, recently, some resources on there, some people just got CVEs from it because they saw this big list of things and was like, these are all CVEs. And I was like, I wish I'd realized there was CVEs. I never know, whatever. Some takeaways for you. There is so many opportunities in this green field for attackers to do ML or for hacking without even talking about LLMs or anything with that. The bottleneck for hackbots is the telemetry. So if you have good telemetry, you may have a leg up on many other people because there is fuck all open source data sets. Defensive tools can be used adversarially. Many defensive vendors are not considering this in the design of their agents, their applications, their APIs. Models of programs. Programs contain malware. What do you know about your business's ML environment? Do you know a ton about it? Do I know more about it than you do? That would not be good, right? You definitely don't want the first time you do an IR investigation in the ML environment to be the first time you've been in the ML environment. It's extraordinarily confusing. Yeah. We have a question here at the front.
So I'm an IR guy. I go in, I find evidence of execution or remote access or whatever in the ML environment. The next question that comes up is what's the exposure, right? Do you have any thoughts as to how you would determine which data exists within that environment?
Yeah, so the data exposed in the environment. Okay, so there's going to be an experiment pipeline, right? And it's going to contain the data cataloged, hopefully by classification. Because if your business works in multiple jurisdictions, that ought to be there. But I can see by the look on your face you don't believe me. Yeah.
I'm laughing out of fear.
Okay, he's laughing out of fear. It's fine. He does believe me. Okay. We have a question you're not allowed to answer. You already won a prize. Don't be like that. Okay. Alrighty. I have a prize here. It's a sealed, I have not opened it, Titan security key. What is the name of the thing that I used to what is the thing I used to explain the individual features of a model when I was doing the malware work of yeah. Come on, Zach, let's not do you. And let's not do you. For now. Does anyone remember the name of the thing that I used to help me make better malware? I used the chess example. Close. What what solution within game theory did I use? Shapley values. Congratulations. Let's come up here and get the politician shot. Here you are. Thank you. Thanks, mate. All right, great. Some shout-outs, some thanks. Mebear, Sayix, Technical Tom, Septillion, Jackson, my blog and the code and all the things that you saw here, literally everything I spoke about, publicly available already. Thank you very much for your attention. Enjoy the conference.